Well, good afternoon. I appreciate everyone's coming out to the DLLC webinar that we have today. My name is Holly Porter. I am the Executive Director of the Delmarva Chicken Association and also the co-chair of the Delmarva Land and Litter Collaborative. Our chair, Josh Hastings, was not able to be with us today. And I really do appreciate everyone coming out. So for a little bit of background, for those who aren't familiar, the Delmarva Land and Litter Collaborative is a diverse group of representatives from chicken companies, from farming, regulatory agencies, environmental and conservation groups. You can see the large list that we have here. And really, we've been working together for the past few years to talk about some complex challenges that are facing the integration of food production, of environmental protection, rural economies, and our communities. And we recognize that these can't be solved in just one single way. So again, it's a wide variety of people that are coming together, trying to work together in solving some complex challenges. Why we were here today, we'll be specifically digging into, I'm sorry, next slide. So again, why we're here today, I won't read all this by any means, but we're really here to talk about ammonia emissions. Again, this is something that's a very complex, challenging topic for all aspects, the environmental and in our chicken community as well too. And this was the discussion that we started a couple of years ago amongst DLLC. And we felt that it was really, really important to bring some science. That's really what DLLC is all about, is to take a look at science and to vet it amongst our many members as well as other scientists about where we are with the management of ammonia, the modeling of ammonia emissions, and identifying where there are still gaps. So we had several scientists present to our DLLC, and then we had a work group that was put together. Primarily, you can see members there. Andrew McLean's a chicken farmer, Kristen Hughes Evans of Sustainable Chesapeake, Alan Gerard of Chesapeake Bay Foundation, Kevin Klein with Virginia's Department of Environmental Quality, Mike Levengood with Purdue, Mount Airs Bill Massey, Alec Echols, myself, and Dr. Schneider, who's going to be presenting to you today. Dr. Schneider is the director of the Virginia Institute of Marine Sciences and the Eastern Shore Laboratory. And he really first became involved within the poultry industry at his work with VIMS when obviously we have a number of poultry farms on the Eastern Shore of Virginia. There was a lot of questions around the poultry industry and how that may have impacts on water quality as well too. Just a reminder, you will use the Q&A feature to answer questions. We're going to hold all questions until the end. We will have a moderator that'll help us with that discussion part. So any questions that you may have, put them in the Q&A function, not in the chat function, and we will try to get to as many questions as possible. At this time, I'm going to go ahead and turn it over to Dr. Schneider.
All right, thanks, Holly, and thank you all for attending today. As Holly said, I am the spokesperson for a large group of people here, a diverse group of people. And I wanted to go through some of the information that we have put together. And this is really a summary of the paper that the link was provided for before, and you can find it on the DLLC website. So when we're talking about ammonia emissions, it's important to understand what ammonia is and how it fits in with a nitrogen cycle. And so how does poultry ammonia fit in with what we know about nitrogen cycling? Nitrogen is a very abundant compound on Earth, and in the air, it is 80% of the Earth's atmosphere is an inert gas, N2, or sometimes called dinitrogen. Now, this is not biologically usable material except for very few types of microbes that are attached as symbionts on soybeans and locust trees, wax myrtle, things like this. They can actually convert N2 gas into ammonium, which is a biologically active form of nitrogen. And there's also a balance here between ammonia and ammonium, and we'll talk about what that difference is in just a second. But in order to convert this N2 gas to a biologically active form, it takes an enormous amount of energy to do this. And so the critters that do this, the microorganisms that do this, are subsidized by these plants. The plants are providing them the energy to do this. Now, it wasn't until 1913 that we figured out how to do this in an industrial process, and it's called the Haber-Bosch process. And this began the production of inorganic nitrogen fertilizers, and still remains a very energy intensive operation in order to do this. So what about ammonia and ammonium, and why are we making a distinction there? So ammonium is a positively charged ion. Ammonia is not. It is neutral. It has no positive or negative charge. The balance between these two forms depends on the pH. Now, pH in acidic conditions below pH 7, the ionized form ammonium dominates. In basic or alkaline conditions above neutral pH, pH 7, then ammonia dominates. So that's really the big distinction between how these forms exist in nature is what the pH of the ambient environment is where they are found. Now, I'm sorry, hang on. Okay, so standard chemical tests. When we measure ammonia, ammonium in the environment, it is all measured as ammonia. They do not distinguish between the standard water quality tests, do not distinguish between ammonia and ammonium. And a single reporting number is used as ammonia nitrogen, and that's used to track environmental nitrogen processes. But these two chemicals are very different. They behave differently in the environment. And one of the big questions is, do the model assumptions that are looking at ammonia emissions and ammonia dynamics in the environment, do they assume that all ammonia is ammonia and not ammonium or the ionized form? That would be very typical because that's the way it is usually handled with environmental ammonia and nitrogen processes. So the difference between these two, ammonia, NH3, exists as a volatile gas, but it also readily dissolves in water. Now, a lot of you are familiar with this odor if you've used household cleaner, ammonia as a household cleaner. It's that volatile gas that's also dissolved in the water in that jug, and that's exactly the behavior of this molecule. It is both a gas and it is dissolved in water. The ammonia gas is a form of concern for poultry litter emissions. This is the form of ammonia nitrogen that is getting into the atmosphere and distributed away from the poultry operations. Loss of gas from the litter in the poultry houses, that ammonia gas impairs bird health. If you've ever stuck your nose in that bottle of household cleaner there, you'll know that it is not a pleasant experience, and it will impair bird health, reduces their growth rate. It also reduces the fertilizer value of the litter. So losing ammonia gas from litter is not something that is really needed, desired, or in fact, people have been trying to find ways to limit that. In contrast, ammonium as an ionized chemical, NH4+, tends to be bound to organic matter in clays and isn't volatile like ammonia gas would be. Oh, I went the wrong way, sorry. So we got ammonia gas in the atmosphere, becomes biologically active, and depending on pH, we get ammonia gas. And so now we're looking at ammonia emissions. Where does this stuff come from? Mostly it's coming from the breakdown of organic material, whether that's by burning fossil fuels or trash or other types of organics, wildfires. We can get ammonia coming out of organic matter. Wastewater treatment plants where organic matter is being digested and converted to CO2. That nitrogen component of it often comes off as ammonia gas. Agriculture and urban fertilizer, that synthetic fertilizer that we've been making since 1913 is also a major source of ammonia emissions. And then agriculture, livestock, and pets. And here we are particularly concerned with concentrated animal feeding operations, or CAFOs. Now, CAFO ammonia emissions have been relatively stable over time, but as other sources of ammonia have been addressed, the CAFO ammonia has become a target. And because it is becoming an increasingly a higher percentage of the total since the other proportions have been reduced. Now, how does this poultry litter end up over here to get to ammonia gas? So a lot of this has to do with growth efficiency of animals and why CAFOs are a source of ammonia. When animals and birds ingest food, only part of the food nitrogen ingested is converted to chicken or beef or pork, whatever the animal is. The rest is excess and is excreted. Now, this depends on the growth efficiency. So if the growth efficiency of poultry is actually really amazing. This is one of the most efficient protein production systems on the face of the earth. And it is astronomical, actually, to see these kinds of growth efficiencies. Things that happen in nature are way, way, way below this. And it's just remarkable what this is. So a lot of the nitrogen conversion is happening into poultry. And as growth efficiencies have improved in the industry over time, then less of that nitrogen is going into the litter and more of it's going into the bird. So this improvements in growth efficiencies is a huge part of this story. Now, if it's a mammal, we convert the extra nitrogen into ammonium, and that ammonium is released in the process of digestion. It's converted to urea, and mammals excrete that in the urine. Birds and reptiles, though, do not produce urine. Birds and reptiles convert the excess ammonium into uric acid, which is excreted as the white part of the feces that you see from birds and reptiles. So we've got plants, grain feedstocks that are going to the birds. They're producing uric acid, which is ending up in the poultry litter. So how do we get from uric acid and poultry litter to ammonia gas? Well, it turns out there's microbes that do just about everything on Earth, and they use uric acid and they produce ammonium in the process. This microbial use of uric acid requires water, and then pH affects the conversion of the volatile conversion of the ammonium to the volatile ammonia gas. This is why the two things that have been targeted by the industry are improved watering efficiency to reduce water getting down to the litter, and also looking at pH amendments to litter to improve the retention of that ammonium in the litter and not convert it to volatile gas. So we've got the complete cycle now. We'll lift off the N2 gas. So we've got ammonium that's in the plants, that's going to birds, that's going to uric acid, poultry litter, and this is where the ammonia emissions are coming from out of the poultry houses. The poultry litter itself is a great manure, great fertilizer, and contains ammonium, nitrate, phosphorus, potassium, and a lot of micronutrients that are often missing from the inorganic fertilizers we use. You look at your three numbers on the fertilizer bags, it's nitrogen, phosphorus, and potash up here. The amount of nitrogen in poultry litter that is immediately plant available is estimated to be about 18%. This varies quite a lot. But it is indicative of the fact that most of the nitrogen in animal manure is bound in organic molecules, and it is microbes degrading those organic molecules that end up liberating that as ammonia or from uric acid. So if we look at broad scale ammonia emissions, this is from NASA Earth Observatory. These are satellite images of estimated ammonium concentrations for the United States. And the one thing you'll notice right off is that when the weather's cold, there isn't much ammonia in the atmosphere. So it's highly seasonal. So ammonia emissions, and a lot of this is from agriculture. You see hot spots like out here in California where there's a lot of dairy and CAFOs out there, and certainly in the Midwest, there's an incredible amount of ammonia coming out there. But we also have some ammonia spots here on the East Coast. And we want to take a little closer look at that. But it is very clear that there's a seasonality to ammonia emissions. So if you're modeling ammonia emissions, you don't use one figure for the entire year. You've got to account for the fact that the ammonia emissions are highly seasonal. If we look at the East Coast US, so this is data from June of 2016, as was the previous graph. So Maryland, Delaware, Virginia, this little tiny bit down here where I am right now, and the rest of Virginia. We see hotspots up here in Lancaster where there's a lot of animal activity, a lot of ammonia down here where there's a lot of pork production, and out in Western Virginia there's some poultry production and animal activity out there. And then we look at Delaware. So here's the poultry signal right here, right? We're seeing ammonia emissions on the Delmarva. what is unknown is really where this is going. So we don't have, this just has June 2016. So we have no idea what the wind conditions were, what the weather conditions were when this data was accumulated. And so we don't know where this is going. We don't know if it's going to Chesapeake Bay. We don't know if it's going to Delaware Bay or offshore in the Atlantic. Prevailing winds would suggest that it's going from the southwest to the northeast. And that would imply that a lot of this ammonia we're seeing on the Delmarva isn't ending up in the Chesapeake Bay unless it is locally deposited. So what about deposition? So here's some real data on ammonia deposition from a source experiment that was done in Europe in 1998. And you can see that over time, the amount of nitrogen that gets deposited is less. This top curve here is the only one you really need to pay attention to. This is the amount deposited and the distance. And you'll see that over time, the ammonia will fall out of the atmosphere, and that this is a log scale. So we're looking at miles here, kilometers here. So miles would be out in this range somewhere. Here's a mile distance from the source. We're still looking at like 12% of the ammonia dropping out within a mile. Now, there have been other data that have suggested this is a more short-term deposition phenomenon than that. This implies relatively long distance dispersal, but again, it's real data. There's been some modeling exercises that show that, well, here's a kilometer right here, so 1,500 meters, 2,000 meters, within a mile, they're looking at most of the ammonia deposition happening within a mile of a source. But again, there may be the difference between modeling and reality, but there are a lot of figures out there that are using relatively short deposition times. And I think this still remains an issue that ought to be looked at a little more carefully. Vegetative buffers is a best management practice that's being encouraged for a lot of poultry operations. And if you look at how ammonia emissions are affected by this, this is the amount of ammonia in the air and the distance from the fans coming out of the chicken houses. This is distance from the chicken house. And the ammonia that comes out is, we say adsorbed, which means is glommed onto, or adsorbed, which means it is incorporated into the plant material itself, both into the vegetative buffers and natural vegetation around chicken houses operations and the landscape. We know that this loss here, so this is within 15 meters. This is within 50 feet of a chicken house. A substantial proportion, and if not most, if not all, is gone within 30 meters. So the vegetative buffers are dropping out the ammonia concentrations in the air really fast. This is not just all captured by the plants, it also it's dispersing it into the air. And I think that difference there, how much is being absorbed and trapped versus how much is being dispersed, is also one of the unknowns that we don't have good resolution on. But it appears that this BMP can be very effective in capturing ammonia emissions, both as particulate matter and as gas. But again, we need to know the fraction between that capture and how much is being dispersed. Now, real data on ammonia emissions, there is a nationwide network for this. You can go to, I don't have that website. If you do a Google search for ammonia emissions nationwide, you can find that website. We did have 4 stations that were established with funding from the Keith Campbell Foundation for the Environment and the Delmarva Chicken Association. They provided the funding for the University of Maryland Eastern Shore and the Maryland Department of Environment to set up these 4 stations to look specifically at ammonia emissions on the lower Eastern Shore. So the stations were downtown Baltimore, for comparison, Horn Point in Dorchester County, relatively remote area of the Delmarva, and then Princess Anne and Pocomoke City. These 2 had increasing amounts of poultry in the immediate vicinity, and so were used as a comparison with these other 2 stations. Data for this effort is here. The Horn Point station has been discontinued. They've collected enough background data there, and we're looking to relocate it. Don't have an update on the status of that, but I'm sure someone may. So here's the data. This is what this looks like from these 4 stations. This is Old Town, this is downtown Baltimore. And you can see that over time, They're relatively constant degree of ammonia in the air. This is Horn Point, which is pretty much 100% ag, forest, and river, although there is poultry within 10 miles of this, and the town of Cambridge and the wastewater treatment plant for Cambridge is within 10 miles of this site. So it isn't exactly completely isolated from ammonia sources, but within certainly within the immediate vicinity of those sensors, there's just nothing there that would provide other than agricultural fields and fertilizer use. If you get the Princess Anne, we're looking at half a poultry house or 0.6 poultry houses per square mile in the 2 mile vicinity of the sensor, but you've also got some urban in this area, but the rest of it is dominated by ag and forest. The Pocomoke station has about 10-fold higher poultry density per square mile. And again, a little tiny bit of urban, but most of this is ag and forest. But the big difference here is going to be this 10-fold increase in poultry. So if you look at these data, so Horn Point is relatively low concentrations of ammonia. You look at Princess Anne, it elevates, and you'll notice the spike here. This is actually anhydrous ammonia application in the field surrounding the sensor that was picking up ag field fertilization as part of this monitoring. But you'll notice that this level is higher than it is for Horn Point. Now, that's also a combination of ag and urban in addition to poultry, but we go to Pocomoke and we can see that there's a higher level of ammonia occurring in Pocomoke, and also more variable in Pocomoke than we see in Princess Anne. So if we look at this a little bit differently, this graph has all of those data summarized as a single point. Scientists hate this because it takes all this tremendous effort and boils it down to one graph. And it's like, well, why do we do all that effort? Well, to make these pretty graphs to tell you what's going on. So Old Town here, here's the average for the year for Old Town, comes out at 6 ppm of ammonia gas. Horn Point's down here at 2. Princess Anne is higher than Horn Point, clearly. This represents really good background for remote areas of the Delmarva Peninsula. Princess Anne, with a little bit more poultry, has a higher elevated level of ammonia, but also has some urban landscape. Pocomoke has 10 times the poultry that Princess Anne does. So we do see a poultry signal here, right? Increasing poultry is relating to increasing amounts of ammonia. And that's clear from no poultry at all, a little bit of poultry, but urban, and then it's 10 times more poultry than there is at Princess Anne. You notice, though, that's not a 10-fold increase in ammonia concentrations for a 10-fold increase in the density of poultry. Another way to look at this is this graph. So on here, we've got that average ammonia value, but then plotting it as the number of houses per square mile. So here's Old Town, Baltimore, the urban signal, and here's Horn Point, and here's Princess Anne, and here's Pocomoke City. Now, it's very tempting to draw a line here between these points, but we need more data in here. There's just too few points to really define this relationship between the amount of ammonia in the air and the poultry house density that's there. And this is really something that is needed if we're going to be accurate about modeling emissions from poultry houses. Now, it's expensive to do this, and this initial project, we collected there is a really nice data set that's collected for that. And there has been another grant that's been awarded to the Socially Responsible Agricultural Project. They just got about $500,000 from the US EPA, and their goal is to establish more stations. So hopefully they will be putting those stations in areas where we can fill in some of the space in here to better define the number of poultry houses, density of poultry houses, and the effect on the ammonia that we're seeing showing up in the atmosphere. So what has been done? Industry has reduced ammonia concentrations in-house, and they do that for bird health reasons. They produce a very high quality protein source and maintain high quality, high health conditions for the birds to make sure that that product is a very good consumer product. And having high ammonia concentrations not only is it affects the growth rate, it affects their bottom line. So the efficiency that they can get by providing good bird health translates into better production, better value for the consumer, but also better payback for the growers and their income they use to survive. So the industry has also had dramatic increases in chicken growth efficiency. I mentioned this earlier. This means less of the nitrogen is ending up in litter, which means less is available to be converted to ammonia gas for emissions. Excuse me, I'm tail end COVID here. I'm coughing a bit. Industry has also improved control of water and watering to birds. And this limits the amount of litter moisture and the caking of moisture, which promotes microbial activity and converts a lot of the uric acid to ammonium, which then can be converted to ammonia gas. So these two things alone have increased the in-house conditions for both the chickens and for ammonia emissions pretty dramatically. There is improved house ventilation management. Most of these growers, the private individual growers are very keen on maintaining adequate ventilation and ventilation management, efficient ventilation management. Vegetative buffers are being incorporated as a BMP. We mentioned that earlier. Most of these operations, if not all now, have covered litter composting sheds and pads, so there's no rain that's leaching material out of composting litter, and the pads prevent any material from getting down into the groundwater. We're seeing improved litter management for field fertilizer use, tracking where litter is going and looking at the applications of litter for fertilizer using nutrient management plans. And a good example of this is the litter app that's available to connect people that have chicken litter with farmers that need chicken litter for fertilizer. And this was something that came out of initial discussions in DLLC, but was followed up by DCA and a grant from the National Fish and Wildlife Foundation, and has been very successful in being more efficient and better control of how litter is being used for fertilizer. So defining and modeling ammonia emissions and their fate is a very complex problem. And people don't like complexity. We like things to be simple. We like to have a target. We like to go after a target and do something about that. But we need to embrace some of this complexity so that we're not doing undue harm. Ammonia deposition is increasing in the Bay watershed and nationally. There's data that show this. Food production ammonia emissions tend to follow a seasonal pattern with greater emissions in warm seasons. It's not constant throughout the year, as some modeling has suggested. Ammonia leaving chicken houses as emissions to air and in litter reaches the Chesapeake Bay, Delaware Bay, Atlantic Oceans, and retained in the uncultivated terrestrial landscape. We have a lot of flooded woodlands on the Delmarva. There's a lot of swampland, a lot of anaerobic space. There are places where ammonia can go that would keep it from reaching the Chesapeake Bay. And this distribution relative to the ammonia emissions on the Delmarva, I think bears a little more close attention. Chesapeake Bay EPA uses modeling assumptions to simulate ammonia deposition and track ammonia under the Chesapeake total maximum daily load regulations for water quality. So this is being worked on, has been being worked on, and it is a tremendous task. It is not a simple thing to do at all. The model estimates ammonia production from house litter, litter storage, application, loss of soil. It incorporates a lot of these variables in it, but there are enormous amounts of assumptions that are being made because they have to be made. We just don't have the data that back up this and deal with a lot of this complexity. The model estimates can be validated by real data, but again, isolating poultry contribution is difficult, just as with those monitoring stations where we've got a mix of urban and poultry. And how do you isolate out that poultry contribution? There are lots of other sources of ammonia in the urban landscapes and even the small towns, wastewater treatment plants, the ag use. Isolating that poultry contribution is difficult, and a lot of assumptions are being made based on chicken growth and trying to simplify that for the modeling exercises. So what has been done? We've seen reduced ammonia concentrations in-house. I'm sorry. We did that. How can modeling be improved? So these are some of the gaps that we recognized in this white paper. that present opportunities. Ammonia emissions from poultry increases with the size of the birds. Poultry houses are not continually full of birds, as some models have suggested. And most ammonia is emitted within the last 2 weeks of the flocks when the birds are at their largest size, and their growth efficiency reduces as they get older as well. Have current litter management practices been incorporated? People are using built-up litter versus new litter. There's amendment uses that haven't always been incorporated. Composting, control of composting, transport, field application practices. A lot of the data that is used is there's a moving window. The Census of Agriculture is usually a few years out of date by the time it gets to the modeling exercises. How much of that is, how much of that is up to date, and does it reflect the current practices? Where is ammonia deposited relative to sources? What fraction goes to Delaware Bay, Atlantic Ocean, and Chesapeake Bay? And how accurate are these estimates? So that I know that those assumptions are being made, but we really could use some additional data in those areas, I think. Vegetative buffers adequately incorporated. How many are out there? Where are they being used? How effective are they? Is it dispersed or is it captured? And how does that be incorporated into the models? How much ammonia is incorporated into Delmarva natural forests, grasslands, flooded woodlands, swamps, wetlands, internally recycled, stored, denitrified back to the atmosphere versus ammonia that is transported to the surface waters? Some of the modeling assumes that all the ammonia produced is all ammonia gas and it all ends up in the Chesapeake Bay. And I don't think that's necessarily accurate. How do we get at a better resolution of that whole picture? How much litter nitrogen is applied to fields? How much of that offsets inorganic fertilizer? Are we assuming that litter used as fertilizer is in addition to the usual inorganic fertilizer use? Or are we incorporating what's being done with nutrient management plans to offset inorganic fertilizer use based on the nitrogen that's in the litter? And how much of that is being incorporated into grains and recycled back to poultry feed instead of bringing new nitrogen onto the Delmarva as inorganic fertilizer? So at this point, I will turn this back over to Holly and as a recap.
So thank you, Dr. Schneider. Really appreciate you not only giving this presentation, but really in helping to take the lead in putting the paper together, working with a work group. Again, it was a lot of work, a lot of meetings. And I think the important part too to remember is with the Delmarva Land and Litter Collaborative, anything that we present, anything that is publicly put out, just like this paper, all has to be vetted by our steering committee members, which we saw in the very beginning, and they all have to approve of what is put out. Is 100% approval that's required. So it's a lot of work. A collaborative is just that in nature. It takes a lot of work and a lot of time, but we really appreciate all of the efforts and all of the work that Dr. Schneider and the work group did. So I think, again, there was a lot of questions, a lot of probably additional data, additional things that need to be looked at or worked on. One of the groups that is doing that, and I see the lead on that group, Joe Wood, is with us. We appreciate you being on. But the Chesapeake Bay Foundation's STAC committee, the Science and Technical Advisory Committee, there is a subcommittee that has been looking at ammonia and asking many of these same questions, and also we'll be working on some recommendations as well, several of which I think fall in line with what's in the paper as well. Again, we talked about that there's definitely some opportunities for research, especially when it comes to the modeling. And there continues to be opportunities to help in educating the public. Again, a lot of what we did early on was to make sure that everybody on the Delmarva Land and Litter Collaborative had a baseline understanding of ammonia, of how it ties in with the chicken industry, as well as the things that are already in place. So at this point in time, I'm going to turn it over to Paula, who is going to be our moderator. Really appreciate The questions, again, if you have additional questions that are specific to the paper, some of the questions we may not be able to answer at this time, because again, some of them may go beyond the paper. But if you do have some questions specific to that, please put them in the question and answer, not in the chat. And our moderator will work in moving forward with those.
Thank you, Holly and Dick. Very informative, and I appreciate all the background. I also appreciate everybody that's joined us here today to learn more, be part of the conversation, and that really is what DLLC is all about. It's dialogue over division and trying to find science solutions and answers to some of these tricky issues. So with that in mind, the whole writing, or much of the writing team, some of the members couldn't be here today, but most of the writing team is present. And so I will address these questions. Whoever from the team would like to answer these, please do. There are a few about the ammonia monitoring. The first I'll say is from Abel Ross. There was a slide showing Dr. Schneider from a drizzle et al. Showing ammonia dissipates within about 30 meters. And can you talk about the distance between the Pocomoke monitoring station and the nearest CAFO? You pulling that slide up, Dr. Schneider? Oh, you're muted.
The stations were established and they drew circles around. So the density of houses per square mile, I calculated from their number of houses within a 2-mile circle. So what was the closest one? I think you would have to go back to the Maryland Department of Environment website and look at that, or better yet, go to, if you have the coordinates for the station from the Maryland Department of Environment website, and then use Google Earth or some other aerial source, and you could look to see exactly where those houses are, which would affect prevailing winds, and how close they actually were to the monitoring stations. So that data I don't have. I just generalized it as the number per square mile based on that 2-mile circle around those sensor sites.
Anyone else from the writing team? Feel free to jump in if you have anything to add on that, but thank you, Dr. Schneider. All right, not hearing anything else. Oh. Let's see, Alec Echols from the Campbell Foundation is asking about the similar monitoring program. Have the ammonia sampling on that group has been supporting ammonia sampling on Delmarva for several years. Can you or someone on the writing team give us insight on ammonia levels and health implications?
Yes. And that's a good point that I missed in the presentation, was that all of those ammonia levels, even the highest ones that were recorded with the anhydrous ammonia fertilizer spike at Princess Anne, and any of the peaks shown at the Pocomoke City station, those are I'm trying to remember the exact figures. They're like 1.5%, certainly less than 2% of any known human health thresholds for particulate matter or for ammonia concentrations from any of those stations. Even urban Baltimore was well below human health thresholds.
Okay, thank you. Courtney Bernhardt has a question also about the collaborative monitoring program that we've been focused on for the last couple of questions. Are pretty clear that the monitors were cited to detect concentrations of ammonia in ambient air. Why does DLLC characterize the monitoring data from these as emissions monitoring?
Well, where else is it going to come from, I guess would be a good question. Yeah, it's characterized as emissions data by anybody doing air monitoring, whether it's the national network or this local network by the Maryland Department of Environment. That's just the nature of it. It is monitoring the emissions of ammonia from the landscape.
Okay. Let's see. I'm trying to group some of these, and they came in together, sort of grouped. I will say that Deb Sauter, who's a PhD with University of Maryland Eastern Shore, she's provided some information in the Q&A that I think others can see. And she's noted that the distances are over 100 meters. I think she means between the CAFOs and the monitoring stations. And it's the MDE project is intended to look at ambient conditions, not single house conditions. And so that helps.
Right.
For the placement. She also put a link to the site for the nationwide ammonia database.
Good.
So I'm going to go back up to the top. Alec Echols, again, Keith Campbell Foundation for the Environment. Can you comment on the use of ammonia for fertilizer, both anhydrous and conventional?
Yeah, I mean, it's part of the green revolution. It's why corn yields, agricultural yields have exploded since really since World War II. After World War II, the industrialization of agriculture, yields have increased dramatically. And a lot of that is because of inorganic fertilizer use, both nitrogen and phosphorus fertilizer use. Anhydrous ammonia is very, very commonly used for corn production. Ammoniacal nitrogen in granular form is also used. Fertilizer is typically ammonia or nitrate as a nitrogen source. I didn't talk about nitrate. Oxidized nitrogen as nitrate is also a plant nutrient. But most of our fertilizers are either ammonia, ammonium, or nitrate, and it is widely used extensively. And if you look at, I think EPA has some nationwide maps of nitrogen concentrations, of nitrate concentrations, and you'll see the Midwest is just lit up with nitrate concentrations from the intensive agriculture that's done out in the plains. It is very, very common use as fertilizer. A lot of it is used as fertilizer.
Okay. Alec added sort of a follow-up comment to that ammonia is ammonia regardless of the source, whether it's,
Yeah, we can't, it's the hard part, is distinguishing poultry ammonia from other forms and sources of ammonia. That's one of the difficult issues.
All right. Let's see, someone else, there are other questions about the monitoring, and so I'm going to get back to those, but is anyone looking at ammonia or ammonium in groundwater and how that affects the general watershed on the Eastern Shore?
I can't speak to the Maryland and Delaware part of Delmarva, but I did a fairly extensive study of stream waters down here on the Virginia Eastern Shore in response to the poultry expansion here. And there is both ammonia and ammonium and nitrate in the streams here, and almost all of our streams are groundwater fed. There's very little runoff. We're so flat here on the Eastern Shore of Virginia. And there's a significant amount of nitrate that is legacy from fertilizer use. We used to be a lot less careful about fertilizer use, and now that fertilizer is recognized as a major contributor to health issues in aquatic landscapes, we're much more careful about fertilizer use. Looking at precision agriculture, also the cost of fertilizer has driven a lot of this. So we're becoming much more efficient at the use of fertilizer, but there's still a legacy of groundwater nitrogen concentrations out there from past high heavy use of nitrogen fertilizers that we're dealing with. You can measure it in the streams. When I compared streams with, so watersheds with or without poultry, I found absolutely no difference in ammonia levels or nitrate levels in streams with or without poultry in the watershed. So I didn't see a signal of it here on the Eastern Shore of Virginia.
Okay. Anyone else from the panel members want to weigh in on that? Okay. All right, I'm going to move on to the next question then. Joe Wood entered this. He's with Chesapeake Bay Foundation and I believe chair of the Scientific and Technical Advisory Committee Ammonia Workshop. Asked, have you been able to evaluate ammonia control measures within close proximity of the monitoring station cited? So similar to a previous question, and is it known if the houses in the proximal airshed included the buffers or amendment use, et cetera?
Yeah, unfortunately, I don't have any other information, and you know, the data are out there. I think, you know, I was kind of bootlegging this off of my other activities, and we really need somebody with the time and a budget to go in and really look at this more closely. And I'm hoping the funding that's been provided to do additional air monitoring, they will take a deeper look at this and a more higher resolution examination of exactly what's being done with the poultry houses in the area of the monitors that they set up. It is needed information.
Okay. Thank you. All right, Alec Echols has another question. Can other ammonia assessments funded by EPA be compatible with the sampling program designed by Maryland Department of the Environment? So you mentioned some of these other programs.
Yes, it is all done by standard methodology, quality control, quality assurance programs. They very, very strict chemical analysis protocols that are followed, data analysis protocols. So yes, it is all intercomparable.
All right. There's a question about Gabby Ross, who I think is still on the webinar. Why were community members who originally demanded an air pollution study regarding ammonia emissions in 2017 left out of the conversations?
I'm sorry, I can't answer that question. I don't know which conversations they were excluded from, or you're in the wrong forum for that question. I think that's more of a social issue that we didn't really address. Maybe someone else has a better answer for that.
I'll just add in that I believe that's exactly why the Delmarva Land and Litter Collaborative is having this webinar, and has also produced the paper. So again, the steering committee members of the Delmarva Land and Litter Collaborative look at a number of different issues, topics, challenges. This was just one of those, and this is the reason why, again, we're having this webinar that is open to the public, as well as the ambient air monitoring data is available on MDE's website and has been so publicly available for the nearly 3 years that it's been studied.
Yeah, thank you, Holly. It has been a long time. This group of writers has spent a lot of time with the leading scientists across the country, so they brought in a lot of technical expertise, and they were very much inclusive of a number of opinions and peer reviews. So thank you for that. Let's see, I'm going to go down to, it's a very similar question, but just to make sure we answer it live, is from Maria Payan. I'm not sure how to say her last name, but wouldn't it be more accurate to characterize the Maryland Department of the Environment monitoring data as representative of ambient air quality, not emissions from poultry operations?
Yes, absolutely. That was the goal. But I think you have to look at land use, because land use affects ammonia emissions. Part of land use where the monitors were located, it includes poultry. And that's why on those graphs, it's listed as % ag, % forest, % urban, and density of poultry houses per square mile. So you try to account for all of those sources, and the fact that we've got a 10-fold increase in poultry density with an increase in ammonia, I think that speaks to poultry as a source. But yes, those stations were set up to monitor ambient emissions, ambient air quality. So it is integrating ammonia sources from the landscape. Now, what's interesting about Horn Point is that integration of ammonia sources from the landscape doesn't reach out to Horn Point. I mean, the Horn Point values were incredibly low. So And there's poultry within 10 miles and town of Cambridge within 10 miles of that site. So that suggests that these ammonia emissions may be relatively local, but again, we need more data. We need more monitoring stations to really define what's going on with ammonia emissions on the landscape on the Delmarva.
Thank you. I got a notice that not everybody could see the Q&A before they were asked. So change that setting so others can see it now. Jeremy Cox from the Bay Journal also said, asked me to repost the link that Deb Sauter put in there. So I put that in the chat for everybody. Again, it's to the nationwide monitoring ammonia data study. Let's see. Deanne Williams asked, any idea how much anhydrous ammonia is being used on the Eastern Shore?
I am not an ag person, so I'm probably not the right person to ask that. But I can tell you that it's very difficult to get. I was sitting in on some of the early DLLC meetings about litter use, of fertilizer use, and trying to quantify all of this. And it is very, very surprisingly difficult to get accurate information on how much fertilizer is actually going on the fields. You can get sales data that are regional, but you have no assurance that it's going on the ground in the same area. A lot of it is proprietary, private information. I think in a general sense, there's a certain level of magnitude that is understood how much is going out there. But when you try to get down to finer scale resolutions, you just will not find the data. So even just trying to isolate the Delmarva, the amount of anhydrous going on the Delmarva, it's difficult to come up with that figure because the granularity of the data doesn't provide that resolution. You don't know exactly how much of that is going to the Western Shore versus the Eastern Shore, Pennsylvania versus Delmarva. It's difficult to tease it out.
Thank you. Maria Payan asked that you mentioned the socially responsible agricultural project that will be using these stations. I'm wondering where you got that information.
I do not. I only know that they've been awarded the funding. Details of their proposal and their plan I don't have, and I don't believe they are going to be using these stations. I think they were looking to do something independent and setting up their own stations, and hopefully that will follow EPA protocols and provide comparable data with what's already happening out there. But I don't think they're using these same stations. They were looking to set up their own independent stations. That's my understanding. I could be wrong. My only information about them was a press release about their award.
Okay. Bud Malone, and I don't have his affiliation handy, but the statement on page 3 suggests windrowing increases ammonia emissions from litter 30 to 80% compared to undisturbed litter is not supported by the references cited and not realistic since all litter is disturbed during layout. I think the question there is, could you address and do you, I don't know if we want to bring up the paper or if you remember what statement he's referring to, but provide any more insight on that and how we reach that solution.
Yeah, I remember there were a lot of conversations about built up litter versus litter handling and windrowing, and it went back and forth. And but I would like to get a hold of you independently, and perhaps we can correct that part of the paper with your information, and also like to acknowledge that Bud was a good source of information early on vegetative buffer work. Yeah, I would stand to be corrected on that part, and I would be glad to talk to you after this, and we'll take a look at that part of the paper.
Okay. Thank you. And it sounds like you all are connected, so that'll be an easy follow-up. Richard Wilkins asks, Dr. Schneider, would you agree that advancements in plant genetics have dramatically increased the efficiency of nitrogen use? And we are getting more output per unit of input than 10, 20, 30 years ago?
Again, I think you better address that to ag scientists and plant scientists rather than a marine scientist, environmental chemical person. So I would say yes. Personally, I run a small farm and have been associated with ag for quite some time. And we do have improved strains, varieties of plants. And I would suspect that the same improvements in efficiency that we see in the chickens, we're also seeing in the plants. And but to get actual hard data for that, contact your local ag university and look up a plant specialist. And I'm sure that they would be able to give you a much better story on that than I can.
Thank you. Again, Deb Sauter, Dr. Sauter from UMES put there's more information available and we can make this available afterwards, but UMES is providing a variety of public outreach events on this and other, I think she says events, but I think related projects maybe. See the UMES extension site for future events. And Dr. Sauter, if you have that link, maybe put it either in the Q&A or in the chat for everybody, that would be helpful. We got a question from Deanne Williams about are DLLC meetings open to the general public? And I will say they have not. We haven't had a lot of public participation, and the forum has been built on these very honest conversations amongst our members. It's an interesting question, and I know some of our meetings we do have public meetings on very specific topics where we welcome and we solicit feedback from different audiences. So any other members of the writing team have thoughts or want to address that?
Sure. So I will, Paula, as the co-chair. So again, we have a steering committee that has a wide variety of membership. We also have some different work groups that occur throughout where you don't have to be a member of the steering committee to be part of that. Of course, we have very specific, mission, vision, and rules of working together as a collaborative. So I would say if there's interest in participating, if there's interest in being part of some of our work groups, I encourage you to reach out to any of the folks, and you can go on our website and see the number of members that are part of our steering committee. And I encourage you to reach out to those folks if there is interest in participating. But at this point, the meetings are not public, mainly because many of them are just discussing the topics and issues specific to our agenda that we're working on.
I put my personal work email in the chat. If anybody does have questions about DLLC or would like to participate in any of our work group members, I would encourage everybody to look at the delmarvalandandlitter.net, which is our website, to get a sense of the topics we have covered and what we are working on right now. And echo what Holly just said. We very much welcome others to participate in these activities and provide their voice and perspective, as long as they're seeking the same types of working collaboratively that the current members do. So I'll leave it at that. Let's see, Jamie Baxter from the Chesapeake Bay Funders Network says, I had to step away for a moment. Can you share more information about what might be learned from SRAP monitoring effort supported by EPA? And I know that's been discussed, but you have a second to maybe reiterate that there is a press release out there, and maybe we can share that in the chat.
Yeah, I don't remember exactly where I saw that press release. I think probably a quick Google search you could find it as quickly as I could, honestly. And it would be really nice to see, what the proposal was and what they plan to do. But it was a matter of days before this webinar that the information came across my desk. So I really haven't had time to explore it.
Yeah. And we can put that on our social media accounts, I think. Why don't we do that and or send it out as an email after this webinar to people who register. But I know we have that link somewhere, just not at the top of the the stack. All right. Deb Sauter put more in there. They will be using mobile stations, to my knowledge, using established methods per the NADP meeting last month.
I would just add in, I can't go fast enough, Paul. I just add in, if there's anyone on the call that has more information or a link to that, please feel free to put that into the chat or the Q&A since there is questions. Again, that's not specific to our paper. But again, we know that there's some additional monitoring. So if anyone has additional information, please add that into the chat or looks like maybe Jeremy has done so. Thank you.
Yeah, and I just put that in the chat. So hopefully everybody can see it in either place, but thank you. All right, we have 2 more questions. So if our panel members are okay, I'll go ahead and ask those.
Mm-hmm.
All right. Courtney Bernhardt, can you speak to the in-house ammonia monitoring that poultry operators do to make sure their chickens stay healthy? Is that data that is reported or available somewhere? And can it help us get a better picture of emissions from individual houses? Thank you.
We don't have access to that data, and most of it is unrecorded. They use it as just an indicator of what they need to do to manage their bird health and their ventilation management. There may be sources of that information that I'm not aware of, but we were not able to get that information. And when you're looking at the emissions that are affecting the environment from poultry, the in-house bird concentrations, they might help, but I'm not sure that they're going to help that much. What we really need to know is how much is leaving the houses and where it's going once it leaves the houses. The in-house ammonia concentrations are also highly dependent on day-to-day changes in humidity, temperature, ventilation. So we'd have to have a lot of that data. And it's also, putting more of a burden on the growers to have to collect additional records. So there's issues with, how much can you get from a private individual who's conducting his own business. And certainly there may be some that are willing to volunteer that, but a level of resolution maybe we're not ready for yet. I think there are better ways to get out the issue without going to the in-house bird ammonia concentrations.
Okay. Thank you. Anyone else? And we're short on time. Okay. I'll give Gabby Ross the last word. So I think others can see this question, but the DLLC doesn't contain any community groups, but cites concern about bias. Dr. Schneider mentioned that he doesn't think ammonia is being deposited into Chesapeake waterways given NASA's monitoring, yet the next slide after that states that ammonia deposition is more likely to happen in shorter distances with a high concentration of poultry operations in specific areas. I'm curious why the locations were chosen to be specifically farther away from the concentrated areas.
Well, I didn't say that it isn't getting into the Chesapeake Bay. I think you misunderstood what I was saying. We don't know what fraction is getting to the Chesapeake Bay. I think some of the models assume all of it is going there, and I don't think that's accurate. Certainly some of it is. I didn't say that it wasn't, I don't think. Holly and the Maryland Department of Environment could probably address the site locations better than I can.
Sure. So I'll speak to that, and also to the point of community. So I live here on the Eastern Shore of Maryland, so I think I'm part of the community. If you look again at the list of members that are part of the DLLC, the vast majority of them also live in the Delmarva. So again, are also part of the community. Finally, as was mentioned in April, I think it was April of 2019, we had done a public workshop at UMES discussing the ambient air monitoring stations. Again, these were meant to be ambient air. We worked with the Maryland Department of the Environment specifically because they are the scientists and the experts on ambient air, more so than the Delmarva Chicken Association or the Campbell Foundation for the Environment. So they were following their ambient air, the ambient air quality standards as issued from EPA, in determining where the locations of the monitoring stations would be. And again, I will say that if you do look at the Pocomoke City monitoring station, there is quite a high concentration of poultry houses around in the 1 mile, 2 mile, and even further out really into the 3 mile that extends into the eastern shore of Virginia as well too.
Thank you, Holly. Yeah, and I think you've already covered this, but we do have a lot of groups represented on DLLC. It is a group that our objective is to bring together the key decision makers from various groups together that can bring the science and the policy together for a meaningful dialogue. And so, and it's been just that for the last 6 or 7 years. And I appreciate that. So again, please email me with any questions, follow our website. I think that those were all the questions in the that were listed in our Q&A section. This has been recorded. We will provide the presentation on our website following this. And I appreciate everybody's time today. Thank you so much. I think the presenters in particular for your time, not just today, but for the last couple of years in pulling this information together, and all the experts that weighed in on this. So thank you.
Thank you again, everyone. Appreciate it.
Yeah,
All right.
thanks, everyone.
Thank you. This concludes our webinar.